Hello, students. We are taking a look now at 8.3. So homework, we've got a chunk of questions. After that, math connections, not a ton. So once again, looks like 1, 2, 3, 4, so 6 of them in math connections. Let's take a look at the homework first, and we'll work our way through here. Now, concept-wise, nothing huge in this area. So which of the following are functions? Notice it says from the set 1, 2, 3 to the set A, B, C, D. Remember, if it's going from 1, 2, 3, it has to have every one of the 1, 2, 3 used because every input has to have exactly one output. Okay, look to see, is it a function or not a function? Draw an arrow diagram with a function domain of this and a range of this. Again, you could have many different answers there. Okay, many different answers. But it does have to be a function. So each input has to map to exactly one output. The number 1 could map to an A or a B. The number 2 could map to an A or a B, but it has to be exactly 1. Okay. Let's see, what did I say? 2, 6 to 7. Oh, I guess I skipped 3. Oh, that's a shame. Well, here probably because I had some of these. Make an arrow diagram for the rule. The rule says when doubled is. So you have to read it. You almost have to read it like a sentence. Like you say, so I start with the number 1. 1 when doubled is, and then you just kind of draw the map. So 1 when doubled is 2. So I draw a little arrow like that. Okay. 2 when doubled is, and then you kind of make the connection there. And this one says is greater than. So again, you have to connect it to whatever it is. So 1 is greater than what? 1 is greater than 1? No. 1 is greater than 2? No. I wouldn't put anything down. So for example, if I had the number 2, right? 2 is definitely greater than 1. So I draw an arrow that direction. Okay. 3 is greater than 2. But 3 is also greater than 1. So I draw an arrow up there as well. So you may have more than one arrow. You're just drawing the relationship. Okay, and then down here in B, it says, now which parts are functions? So that's second question. That's the follow-up. Make sure that you read that carefully. Answer the specific pieces. Dosage of a drug is related to the weight of a child. Oh, that's true. Oftentimes they'll ask how much the baby weighs before they prescribe a certain amount of a drug. 50 milligrams of the drug, and an additional 15 milligrams for each 2 pounds or fraction of 2 pounds of body weight above 30 pounds. Okay, so when it says or fraction of 2 pounds, it means this is going to be a round up function, right? So if, I don't know, if your baby is 11 pounds, right? Then for each 2 pounds, that would be 5 groups of that, right? Because 2, 2, 2, 2, and 2. So that's 5. Then for the next fraction of 2 pounds, even if you have a little bit left over, you have to count it as the next one. So you get an extra 15 milligrams as well. Let's see here. What else do we have? 1 through 7, 9, and then skip 10. Okay, so Quick Talk advertises 50 cents a minute for the first 60 minutes, but only 10 cents a minute for each minute thereafter. I love it. So these authors, they are pretty old now. And so they still remember back when the biggest thing about a cell phone plan was when you had to pay per minute. So to be honest, this probably should be updated into something about how much data, how many megabytes of data, how many gigabytes of data you're using. Right. It's how much people talk on the phone. All right. So anyway, there you go. So make a graph. Yeah, showing the cost per minute. Connect the points in the second graph. Connect the points in the first one, and what you'll see is 50 cents a minute for the first hour. But if you talk for more than an hour, then they cut the rate down to just 10 cents a minute. So the graph is not going to be a straight line. There's got to be some kind of change in the middle of it, right? And let's see, what else do we have here? 9, 11, and 12. Okay. Ooh, function machines. So this is kind of fun. Find the final output for each of the following inputs. So when you say 6, put 6 in, bump, bump, chicka, chicka, bump, bump. Ooh, what did you get out? And then drop that right back into the next one. And that becomes your output. Okay. So there you go. There it is. Let's see here. What else do I have here? 11, 12. In problem 11, find all inputs for the final output equals twice the input. Well, that's a good one. Then you got to do a little bit of work. That's not a bad one at all. I like that. 11, 12, 14. Consider this function and do the following. So a little bit with composition. 15. Here's a function that assigns the nth term of a sequence to the number of the term. So if t of n equals 4n minus 3, determine which of the following are output values of the function. Then determine which of the following are in the range, which of the following are output values. Those are basically the same question. But again, it's just asking you how you would do that. And you're just checking them, right? You're just saying, is there a way that I could get the number 2 if I'm doing n times n minus 1? Because these are numbers in a sequence, right? So if 3 was my number, 3 times 3 minus 1 would be 3 times 2. 3 times 2 is 6. So 6 would be in the range. And you come down here and you say, well, what about this one? Plug in the number 2. 2 times 2 minus 1. 2 minus 1 would be 1. So 2 times 1 would be 2. So, okay, perfect. Yeah, that would work. Okay, so that's what we're looking for. Let's see here. Did I assign 17? See, I skipped 17 because I already did one. We already did kind of a function one with the little function machine, so I chose not to do that one. And 18. Oh, here we go. Relationship between the number of cars on a road and the time of day. Okay, now some of you are like, hey, yep, that's the traffic pattern. If I can get out of the house early enough, there's not very many cars on the road, right? If you're coming, maybe you're taking the 15 down, maybe you live in Temecula or something like that, right? You're like, oh my gosh. If you wait long enough, all of a sudden, 6 to 7, 7, 8 o'clock in the morning, you're like, okay, this is about it. This is great. And then, of course, once it gets past, say, around 8:30, all of a sudden the amount of traffic seems to be dropping off. People have arrived at work. They've arrived at school. So the question is, when was the increase? What was the increase between 6:30 and 7? During which half hour was the increase the greatest? We're asking you questions about a relationship, and then we want you to see something visually. So this is not a table of values. This is a graph. Okay, 18, 20 to 21, and then 23. So 20 to 21, these are toothpick or matchstick sequences. Okay, total number of matchsticks, how many total? And the next one is how many squares do I get? So if I start with 1 square and I cut it, I get 4 squares. Then the next one, I cut each of those. How many total squares do I have? And your goal is to find a pattern. And there definitely is a pattern here. Might even be a sequence. All right, and the last one was 23, which is this graph right here. Now notice it does flow onto the next page, so be careful as you read. Which of the following are graphs of the function and which are not? If a graph is not a graph of a function, explain why not. So can you look at this picture and determine whether it is a function or not? Just remember, what's the key behind a function is each input, that would be each x value that you have, every single one of them, no matter where they are, has to map to exactly one y value, exactly one. If you see that an x value maps to more than one, it's not a function. Okay, so as you go to the next page, there are a few additional pieces there. Oh, shoot, I was doing A. I mean, it's virtually identical for B. I guess I should say the same thing. Let's go take a look. I know I was just doing A. But let's just see. Does it look? Wow, these look almost identical. I mean, they really are. A and B are basically the same thing. Let's go down and see. Yeah, and here they are. Which of these are functions and which are not functions? So let's see here. 20 and 21 over here would be just, again, sequences of tiles or sequences of matchsticks. Okay. So as you can kind of see, as you move from one shape to the next, some of the shape remains. You're adding pieces on. How many did I add on? You might be able to see a nice little pattern every time. Here, I start with 2, then I have a 2, then I add this, then I have a 2, then I add that to it. So again, think of what you're changing as you go forward. What's changing? How much am I adding each time? All right, that is it for the homework section. Again, if you have specific questions, please let me know. 8-3. Boom, mic drop. We are almost done with chapter 8, and that'll do it for right now. All right, if you have questions, let me know. I can meet with you in Zoom. I can meet with you on campus in person. I can even stay around after class most days and chat with you if you have other questions. And I can also make a video for you that is specific to the questions that you might have. Hope that helps. All right, off you go.